Okay, so here I am at the observatory. We are going to do some asteroid imaging tonight. This is the telescope on the mount here. You can see sitting on its pedestal, on its base. A little cheesy counterweight there. This up here is the telescope control panel. This is the computer in here that controls the telescope. Right there, power supply. CAN dongle, PCAN dongle, and I have what I've done here is I've taken a dark for my flats. I took sky flats tonight and I'm shooting some darks with them, and what the flats are, the camera here, I just point, and during twilight I point this telescope at the sky, the twilight sky, and I take several images to see what the capture any dust, or to uniform, make the background uniform, basically. Something else I wanted to mention has to do with the tilt sensor. This here, this thing here is my tilt sensor, and it's supposed to be mounted in the back of this, the telescope, like that, but it's not. And then what I do with that is, I use that, it's kind of hard to see here, I use that to set the telescope at zenith. So that's how I find my reference stars. I use this tilt sensor, which talks on CAN. That's a CAN bus based tilt sensor made by, I forget who makes it, I think it's Infineon, and it talks to the CAN controller. There's a CAN interface inside my paddle here, and then that talks here on the screen here. Hard to see, but that's right there, that's the tilt. And here I'll put the sensor back on. Get that in focus, and you'll be able to see that it's pretty close to zero. And that means it's pointed up, and that means, because I know what time it is and the position, I know what the telescope's pointed at, and I use that to zero out the coordinates. So one thing I hope you can see is that this here, this is the Sky X, this is my charting program, and this little spot here shows where the telescope thinks it's pointed based on that zenith position. So it looks like there's a reference star really nearby. So what I'm going to do is I'm going to turn on tracking, and I'm going to line that up into the finder scope, and then see if I can get it in the main camera, and then I'm going to make another better and more accurate zero by position. Okay, going a little north, nudge it a little north, nudge it a little to the west, a little north, a little west. And then I'm going to go look in the finder, and hopefully it'll be there, and if not, I'll just position it right into the middle of the finder, and then I will zero that, and then I'll check it in the main camera. I've shot reference star, the star that was the star we were close to. It's actually this star. It says we're way off. I found it in the finder, because the zenith method will get me the star in the finder scope, which is a couple degree field of view. Center the star, get it on the camera, and then resync. And then I'm going to start focusing next. So I'm going to focus, we'll get it synced up, and I'll get us also on. I'm on the high accuracy tracking setting right now too, which is what we want. Okay, I've synced the telescope onto the star by typing in over here. I've typed in the coordinates in the JNOW local coordinates, and I click sync, and now I've synced them up. So it's telescope is reporting to the sky the correct position over the serial port. So now I'm ready to deal with the focus issue, where you can see I have a lot of donut hole stars, and so I'm going to have to refocus those. And so to do that, I go into here, camera, focus, and it will grab me a little frame. I only need about a 1 second exposure probably. And it'll grab that, and I'll pick a star field to focus on. And you can see it says it's downloading an image. take a little while, it'll frame it, and then it'll start rolling over that, and then I'll get the image in focus. And once I'm in focus, then I can work on the guiding camera, get the guide camera set up, and then we can start working on our target. So here is my area of interest. I'm going to pick a faint star because as I start focusing in, it's going to get brighter and brighter. So I say that, I say resume, and it's going to start in this very small area, exposing and then giving me an image of that very out of focus star. And I'm going to go over to the telescope and I'm going to focus with a focus knob here. Unlock and focus with the focus knob to see if I can get that guy sharper. So I'll work on that for a little while. That's the wrong way. Okay, here you can see I've done a little better now. I've been able to pick up another star. So that's pretty good. I might just leave that. I might just call that, declare victory on that and call it good. Okay, so I've got the main camera focused. I don't have guiding calibrated, and one thing I often want to do is go to a star cluster to get my guide camera focused and calibrated. And so I'm going to go, and way up here, I'm going to go all the way over to M67 and make sure that I get a good focus, because target's going to be at a much lower declination. For these asteroids are usually going to be at a much lower declination, more on the ecliptic, so that's where we're going to go. So a little south and west. I want to work my targets that are on the west before they go too far down too. Always keep watching the cables so nothing binds. A little more south. I might resync over here too. Pretty far to the west. In fact, I might use M44. It is quite far to the west. Yeah, it's a little bit. Okay, so I got myself back in focus and I picked a star I kind of like, and I'm going to go ahead and see if we can get a guide on it, get a guide calibration. So now the telescope is trying to calibrate on that star. And you can see I'm still looping in focus on the main camera. It won't, oh, it's off, but let's see how PhD is doing. It's moving, oh, now it says it's guiding. So let's see how we're doing on our graph and look at our profile. Let's look at the profile. See how bright this star is. 1.2 arc seconds across. Nice bright. But now it's complaining because now it's just, now it thinks it's a little too faint. So it's not really getting a good guide on it. It's kind of hasn't really got itself going yet. Sorry, I was off. It was off. That nice 1.16 arc second, really nice narrow star profile, 1.13 arc second. That is really amazingly good seeing. That is not a very bright image. So I need a brighter guide star. Okay, this might be a little hard to see, but you can, if you look carefully, you'll see our moving asteroid. So we've got one of our guys back. One of the asteroids that was in the wrong position. You can see those three spots there moving along at a reasonable pace. That's about 18.5 magnitude. asteroid, so that's pretty good. It's reasonably bright, and so that's between a 180 and 300 second exposures, and moves slow enough that it's not a problem. So we'll take one more exposure on this guy for tonight, and then we'll call it good on this one, and we'll try to shoot it again and get a 2-day track, and then we'll go to a fainter target, a more interesting recovery target that was isn't numbered yet. So this one is unnumbered, but does have an orbit calculated, but it's a pretty bad orbit. So we're going to send this one into the Minor Planet Center and give them some better information, and then on to the next target.